Alright, so this is a formula for present value of a compound interest. Alright, this is the formula. So P stands for present value, A stands for the future value, R stands for the rate, M stands for number of compounding, N stands for number of years. So we're going to solve a question on this. Alright, let's go on. Okay, a man saved the sum of 20,000 naira in a fixed savings account. After 5 years of a rate, not of a rate, please let's go back to this, 5 years with with the rate, with a rate of 7.5%. Alright, so the question is, what was the original amount invested given a quarterly compounding? Alright, let's go again to the question, guys. Let's go again to the question. Alright, now a man saved the sum of 20,000 in a fixed savings account. Alright, so after 5 years with a rate of 7.5%, what was the original amount invested given a quarterly compounding? So assuming the money was compounded quarterly. Alright, so what was the original amount invested? So we'll throw out the formula again to help us solve this problem. So the formula for principal, which we are looking at the current amount invested, is A bracket 1 plus R over M bracket N times M. Now in my previous lecture, I was able to explain to you guys the scenario for M. M can be compounded annually. So if it's compounded annually, M becomes 1. M equally can be compounded semi-annually. So if it's compounded semi-annually, both M's becomes 2. Quarterly, M becomes 4. Alright, monthly, the value for the M's becomes 12. So depending on how it is being compounded. So let's go back to this question again. So from there we have the future value of the investment or savings is 20,000 naira. the negative here. 20,000 naira. Now, the brackets we have is 1. I'm going for the formula. Now, the rate is 7.5%. All right, this rate is 7.5%, which is 0.075. All right, over now M. The question repeats. The question. Let's go back to the question. All right, the question told us that 7.5% is the rate. All right, like what we said before, this is the future value of the amount after 5 years. And now if you go back to the question again, we have something like quarterly compounding. So it's compounded quarterly. So we are going to solve in that light. Now quarter compound, it's 4. All right, we have minus n times m. So first, the rule is you are starting with the bracket. Now starting with the bracket, we have 1 plus. Now let's solve for 0.075 divided by 4. So let's move over to our calculator. So from here we have 0.075 divided by 4. All right, so what we have is 0.019. So I'm going to get it into 3 decimal points. So it's 0.019. So let's go on. So we have 0.019, bracket close. Now n, let's be done with this. So we have 1.019. Don't forget the formula. The formula says the ones in the bracket raised to the power of n minus n times m. Now the n is the number of years. So from our question, the number of years from our question, let's go back to it, is a period of 5 years. Okay, from our question is a period of 5 years. So let's go to the solution. So we have 5. So minus 5 times, since it's compounded quarterly. All right, since it's compounded quarterly, so it just minus 5 times 4, which would be, let's go back again, which would be 1.0, okay, 19 to the power of minus 20. So we are going to look for this in our calculator. 1.019 raised to the power of minus 20. So what do we have? 1.019 raised to the power of negative 20. And we have 0.686. So 3 decimal points, 0.686. So we have 0.686. So this value we have is called, since we are taking it to the present from the future, it's called a discounted factor. Sorry guys. The value we add is called a discounted factor. So let's solve for the present value given our discounted factor. What we just simply do is to multiply whatever we have here by our future value. So let's go ahead. 20,000 times 0.686. So 20,000 times 0.686. So let's visit our calculator once more. So 0.686 times 20,000. All right, so we have 13,720. 13,720. Sorry, guys. Okay, you have 13,720. So what it means is that the original amount invested was 13,720 for the period of 5 years at the rate of 7.5% compounded quarterly. Guys, thank you for watching. Now, just note this quickly, that our M from the formula, all right, our M from the formula, all right, was 4 because it was compounded quarterly. So if it was compounded monthly, our M should be 12, both the power M or the one under the rate should be 12. So you solve it for that. If it's compounded semi-annually, it should be 2. Alright guys, that's fine. Have a nice day, guys.